In this video we're going to discuss the production of urine and how it relates to an animal's habitat and niche, that is, how they're designed for their environment. Now, just recall that the unit is actually called excretion, and excretion means we want to get rid of waste products. I mean, a lot of people think that the reason that we urinate is because we drink a lot of water. Actually, it's the opposite. The reason we drink a lot of water is that we want to urinate. And the reason we want to urinate is we have to get rid of what's called nitrogenous waste. And nitrogenous waste means the products or byproducts we get here from our metabolic processes. Remember, proteins are pretty much made of amino acids. Amino acids are filled with nitrogen, and we have to get rid of that stuff or else it's toxic. So that's nitrogenous waste. So you have to have some molecule which can carry a lot of nitrogen. Now there's three molecules that animals tend to use: ammonia, urea, and uric acid. And you can see that all of them contain a lot of nitrogen in them. So there are good ways to get rid of it, and that's why we urinate. And the reason we have to have water and salt is you have to have some sort of transport mechanism that'll carry it out. So if you throw food down a garbage disposal, for example, it just sits there unless you run water through it. But the important idea is that we really didn't want to get rid of the water and salt. We wanted to get rid of that nitrogenous waste. Now, let's take a look at what animals would prefer these three types of systems. Ammonia is very, very simple. Fish like to do it that way. Why do they do that? It requires very little energy. So, a simple system for them. The bad part is it's toxic. So how can they get away with that, though? Well, remember, they live in an aquatic environment. So the minute they urinate out ammonia, it gets diluted right away in a large volume of water. That would work for them. Definitely wouldn't work for those of us who are terrestrial animals. How about uric acid here? That's the type performed by birds and reptiles. Now, it's almost like a solid. It's semi-solid. They reabsorb so much water that their urine actually becomes semi-solid, and that's what that white poop is that you often see on your car windows here. Now, why do they have to have a system which reabsorbs a lot of water? Well, because remember, they start off in eggs, both reptiles and birds, and if you're inside an egg, your water situation is very limited. You have no access to new water, so you have to reabsorb everything that you got. So their lifestyle is based on the fact that embryonically they started off in eggs. Now, mammals like us, we prefer urea. And urea is kind of an in-between situation. It requires a moderate amount of energy, not a lot of energy like uric acid where you have to reabsorb all that water. But it's not a big deal for us because we can always drink water, assuming we're not lost in the desert there. So it's moderate water reabsorption and moderate energy. Okay, now let's take a look now at the environments of animals and how their kidneys would have to adapt to their particular situation. And I'm going to divide our environments into three categories. Let's call them freshwater, like trouts in a lake, marine, sharks out in the ocean, for example, and terrestrial, mammals and so forth like us. Okay, let's look at the freshwater fish first of all. Now, what are their problems and what are their adaptations? Well, it has to do with the amount of water and the amount of salt that their environment has. Okay? It's all about osmosis. Remember that water moves osmotically. That is, to remind you, water will move to dilute salt. So if you're in a very salty environment, it would pull water out of you. That's why we don't drink seawater. Okay, let's take a look at a freshwater fish. What's their problem? They are hyperosmotic to their environment. Now, what does that mean? It means that the fish has more salt than the water. It has more salt than the water. So which way would water move? Water would move from the lake into the fish to try and dilute the fish's salt. In other words, they would be drowning in the lake because water is coming in through their skin and entering into their blood. That's a big problem. They'll also have a big problem because since the lake doesn't have a lot of salt, they will little by little start to leach out and lose salt. Okay, so what is their solution to the problem? Well, first of all, they have special glands which help them to reabsorb salt. And that's why if you have a freshwater fish tank, you have to always add kind of some salt in there to keep them going there. They also have a very, very large kidney. In other words, they have to be processing water and urinating all the time, or else they would be drowning in water. So very, very busy kidney to get rid of that water all the time. Now, marine fish is exactly the opposite, right? Now, marine fish, if they're living out in the ocean, which is 7% salt, the ocean is saltier than the fish. So the fish would be hypoosmotic. Hypo means here that they have less salt than the seawater. Which way would water move now? Well, if they're less salty than the seawater, water would be sucked out of the fish to go into the ocean to try and dilute it. But of course, you're never going to be able to dilute all the salt in the ocean. So the fish is constantly losing water. And they're also, since they're in a very salty environment, constantly filling up with salt. So they would have to have a kidney solution, which was exactly the opposite. They would have to have special glands which excrete, get rid of the salt which is coming into them. And since they're losing their water, they would constantly have to have their mouths open, drinking more water. There are some other marine animals, by the way, that don't fit neatly into the fish model, like shark, shrimp, and crabs here. Same problem as seawater. I'd like to just talk, for example, about the sharks for a moment, though. That's kind of an interesting one. Sharks have come up with a different solution because of oceans being very salty. They are isoosmotic. That is, they have a salt concentration in their bodies which is exactly equal to the ocean. So they have perfectly adapted to their environment. And how do they do that? They can't do it with sodium chloride because they would be losing sodium chloride and gaining it, just like the other fish. So they have to have a salt which they can really hold on to, something bigger than sodium chloride. They use urea. Their blood is filled with a very high concentration of urea, which makes them isoosmotic with their environment. How about some marine mammals that live in there, like our friends, the whales and the dolphins, right? Well, they're living in a very salty environment, yet they are mammals, so how do they get away with it? They also have a very, very salty body inside there. They are hypertonic or hyperosmotic, so they have more salt than the ocean. And because they have more salt than the ocean, they just don't drink at all. They hold on to all their water. So water flows into them. They never have to drink. People have this crazy idea that, how do dolphins and whales drink? Well, when it's raining out in the ocean, they just turn upside down and open their mouths and gulp in water. No, they don't. Bottom line is, they just don't drink at all. Now let's go on land here, terrestrial animals. Now, we're not living in an aquatic environment, so our conditions are not as extreme. Our problems are simply basic old water loss because it's hot, water evaporates, and we have a very simple solution. We just drink. We try and conserve our water, so our kidneys actually absorb quite a bit of our water. We have 6 liters of blood. We definitely don't urinate that much each day. We try and have kidneys that will reabsorb as much of our water and conserve as much of our salt as possible. There are some special terrestrial situations where we go to the extreme, like seabirds or seagulls. People always wonder, can seagulls drink salt water? If they're out in the ocean, hundreds of miles out there, can they drink salt water? Yeah, they actually can. We can't. That'd be a big problem because it would be bad for our blood, but they can. How can they do that? They have special glands. If you look at a seagull right above their nose, right, you will see that there are little holes there. And those are actually salt-secreting glands. So they extract out the salt, and they just drips out of their nose, and that's how they're able to drink seawater. Another extreme example is your good old desert rat, or really any animal that's living out in the desert there. There's very little water, so what do? They have a kidney that almost reabsorbs 100% of their water. So in other words, they just never, ever urinate. And I think that's probably a